Okay, everyone, let's continue looking at Module 26209-23, Grounding and Bonding in the NCCER 11th edition. This section will be 2.00 Grounding Methods. Service grounding methods. All electrical systems must be grounded and bonded according to NEC requirements. Grounding systems protect against lightning, surges, and abnormal voltages. Requirements for grounding are found in NEC Section 250.24. Methods of grounding are found in NEC Article 250, Part 3. It's grounding for industrial and non-industrial applications. In the industrial application, they have a cold water pipe, a metal in-ground support structure bonded to a ground ring of bare copper not smaller than number 2 AWG, an electrode encased in at least 2 inches of concrete at the bottom of the footing, consisting of at least 20 foot of 1 or more half-inch steel bars or bare copper at least number 2 AWG. If more than one method exists in one building, they must all be used and all bonded together. In our residential application, they have the main panel board connected to the neutral bus, they have a grounding electrode conductor, they have a metal cold water pipe, and a grounding clamp. The connection must be made within 5 foot from where the point of the pipe enters the building. They have a ground rod connected with a grounding clamp. If I use more than one ground rod, they must be spaced more than 6 feet, at least 6 feet apart, and I do not want to use a metal gas pipe. Ground rods must be able to withstand and dissipate repeated surge circuits, corrosion resistant, and rugged enough to be driven into the earth. The grounding electrode conductor is the sole connection between the grounding electrode and the grounded system conductor. NEC 250.64 provides guidance for grounding electrode conductor installation. A common grounding electrode conductor is required to ground both the circuit grounding conductor and the equipment grounding conductor. Sizing the grounding electrode conductor. NEC Table 250.66 gives the proper sizes of grounding electrode conductors for various sizes of electrical services. NEC Table 310.16 is used to determine the size of the service conductor from its ampacity. Most applications use copper conductors with a rating of 167 degrees Fahrenheit or 75 degrees Celsius. Once the size of the service conductors is known, the size of the grounding electrode conductor can be determined from NEC Table 250.66. Installing the grounding electrode conductor. The grounding electrode conductor must be one continuous length except for the following condition. Splices and bus bars are permitted. Where a service consists of more than one single enclosure, taps may be connected to the grounding electrode conductor. Bonding jumper or jumpers from grounding electrode or electrodes and grounding electrode conductors can be connected to an aluminum or copper bus bar not less than 1/4 of an inch by 2 inches. Wire-type grounding electrode conductors may be spliced at any location by means of irreversible compression-type connectors listed for the purpose or using exothermic welding process. And some examples of installing the grounding electrode conductors and splicing them. And warning, exothermic welding is a hazardous process that should be performed only by qualified personnel. Refer to your company's safety procedures and the manufacturer's recommendations before using exothermic welding equipment. Other electrodes. When an electrode that meets the requirements of NEC Section 250.50 is not present, the following electrodes may be used. The local system, such as a local metallic underground system, such as piping, metal, well casing, and tanks. Rod and plate electrodes, such as pipe or conduit electrodes not less than 8 foot long. Or plate electrodes. Plate electrodes must be a minimum of 1/4 inch thick if iron or steel, and 0.0 inch thick if non-ferrous metal. A trade term for this module, and some review questions for this module. Assuming the use of 75 degrees C copper conductors, a 200 amp commercial service would require a 1 aught service conductor, a 2 aught, a 3 aught, or a 4 aught. I'm going to go with a 3 aught. A ground rod must be installed in a coastal location and can only be driven halfway before encountering a rock shelf. One legitimate alternative is to bond and bury 2 4-foot lengths of ground rod. Allow the 4-foot section to protrude above the ground. Bury the rod in a trench at least 30 inches deep. Bend the rod in a U shape and drive both ends into the ground. Bury the rod in a trench at least 30 inches deep. Okay, everyone, that was it for that section. The next section will be 3.00, equipment grounding, and I'll see you over there.